In this lesson, discover the right way to test a three-wire sensor and avoid the most common missteps by verifying every path: power, ground, and signal. Three-wire sensors are everywhere: map, throttle, position, and more. Many code readers or quick checks focus only on the signal wire or scan data, missing critical faults in power or ground. Without a complete approach, you might misdiagnose the problem and replace a part that isn't bad. A three-wire sensor relies on a regulated power supply, a solid ground reference, and a signal line. The ECU reads the voltage between signal and sensor ground, expecting a value that accurately tracks physical conditions. If any path is missing or compromised, the ECU may see a signal, but it could be wildly wrong or stuck. To test a three-wire sensor, backprobe each circuit at the connector. With the sensor plugged in and key on, confirm the supply voltage, check for a low-resistance ground, then verify the signal changes with the physical input. Loaded testing catches hidden faults, like poor grounds that pass a continuity test but fail under load. Scan tool data shows what the ECU interprets, but a faulty ground, power feed, or sensor can trick the module, giving believable but false numbers. Always compare scan values to your meter results. If live data and direct measurement disagree, trust the physical meter and track down which path is faulty. Modern ECUs often run plausibility checks, comparing different sensor inputs to catch impossible values. But if both ground and power are offset, signal may track, but altogether still be wrong. Cross-checking related PIDs or comparing sensor response to a physical event breaks this trap. One of the most expensive errors is replacing a sensor only to find the issue was a broken wire, low 5-volt feed, or bad ground. Always prove power, ground, and signal in action, and compare scan data to meter readings before making any part decision. Start by confirming circuit power and ground under load of the sensor. Next, check signal voltage response to physical changes. Compare meter to scan data. Only replace the sensor when all circuit tests pass, but the signal remains faulty. This flow catches wiring, connector, or module problems missed by single measurement shortcuts. The right sensor test means checking loaded supply voltage, a known good ground, an active variable signal, and always cross-referencing direct measurements with scan data. This is how you prevent wasted time and costly unnecessary sensor swaps. Remember, full path testing saves you from costly mistakes. Proving every wire at the sensor connector is the only way to truly trust your diagnosis.